Okay, folks, welcome back to Swift on Sundays. We're slightly behind schedule here, which is my fault entirely. I just bumped my OS to OS 10.14.4, and of course that caused my streaming thing to go a bit crazy. So apologies for that ahead of time. It all seems to work. If there are any problems, if I'm too quiet, whatever, please go ahead and say in the chat. As a reminder, if it's your first time at a Swift on Sundays performance, and they are performances really, I ask very kindly you avoid all kinds of harassment or bothering of other folks. I have an instant ban approach to that, so please leave folks alone regardless of their attitude to life or what kind of person they are, otherwise you will be banned. If you have questions, that's awesome. Go ahead and ask me. If they're about the current topic, ask them immediately. If they're about something generally very interesting, but not what I'm doing right now, please hold off. Wait until later on, basically, after the mainstream is finished. I find it awfully hard to jump back and forth between, Paul, what to think about Flutter, and Paul, current project you're working on. So it's awfully challenging to do. So please avoid doing that if you'd be so kind. It'd be nice. The project today, I see some folks have been asking about it. Today's project is going to be another SpriteKit game based on a popular request from attendees to the last one. Folks asked for more SpriteKit. And I've taken a game I actually made for my book, Hacking with tvOS, and I've modified it to be more exciting in a Sundays approach. So I've taken out some things and added some different things to make it more varied. And it's a space shooting game, which is easy enough in theory. There's a bit of physics, some particle effects and so forth. But I've added in lots of Codable in there, so we can load our data from Codable, and also added in core motion support. So this is another one of those examples where I have to try and use a live iPad to demo my game, which means, of course, an extra layer of hilarity. That might go wrong at any minute because I'm using a live iPad, so I can use core motion. You know the drill. If it doesn't work, we'll just get on with it and move on. So far, in the 11 weeks we've had so far, there has been no major failure, which is great. But, any minute now, we never know. David King, thank you very much. You're most welcome. I'm glad you're enjoying them. I did, by the way, promise to do an easy one of these weeks, and it hasn't materialized yet. I keep on doing increasingly hard ones. I apologize. This is another long one. Hopefully, next week. Definitely next week. We'll make next week be an easy one for sure, because I realize it can be quite tiresome always doing hard stuff. So hopefully, next time will be easier. So, I don't want to waste too much time chatting away. I kind of want to get on with it straight away. So I'm going to go ahead and try and share my screen, and we can dive into Xcode. Let us get rid of that window. There's so much junk on my desktop here right now. It's really, really, really messy. I'll go ahead and share my desktop, and we can get started in Xcode. So, boom. Okay. So hopefully you're now all running Xcode 10.2 with Swift 5, which launched like a few days ago. If not, the rest of this talk may be confusing. I think it's entirely 100% backwards compatibility to 10.1 and Swift 4.2, but obviously I'll be using 10.2. So if you haven't got that, I recommend you upgrade. I'm going to launch Xcode now and choose File, New Project, like that. And so we're doing SpriteKit here. Now, I've said before, Apple's built-in SpriteKit template is pretty nasty. So I have to use that and kind of clean up like usual. So I'll choose the game project. I'm calling this game Zaptastic. And then press Create on my desktop. Boom. Just like last time, we're going to do that cleaning step to make this template less awful. To make this game significantly easier to make in the sort of 90 minutes we aim for, I'm making it an iPad-only game. So please change devices from universal to be just iPad, and then ditch portrait upside down and landscape left. It's only landscape right. We are going to use tilt control, so having the rotation thing will be confusing. So you want to get rid of every rotation apart from one rotation, otherwise it's confusing. And I believe it'll complain as you also check the requires full screen box. So do that as well. Okay, the cleaning. We're going to clean up this template so it's less awful. And that means, firstly, ditching actions.sks. That's awful. That can go away. It means ditching most of GameScene SKS, which is this big label, basically. Get rid of that. and the inspector change the size from this frankly bizarro land size here to be 1024768, which is the approximate size in points of most iPads. Obviously, there's some fluctuation in there, but that will look great on nearly every iPad out of the box. We also want to go into gamescene.swift and get rid of nearly all the code. So scrap the gameplay kit import, scrap these two properties, get rid of all of did move to, all of this, all of that, all the other code, get rid of it all apart from the ending brace. That's what you actually want to aim for by end of it if possible. The slimmest possible SpriteKit template. And this really, it's the SpriteKit version of a single view app template. Here's the least possible code required to get up and working with SpriteKit. So yes, please use that. It's a good idea. I do have some pictures for you, some assets to work with. And I'm going to try and get the URL up on the screen. I'll probably paste it into the chat window for you so you can see it. It is, hopefully, let me just try it myself first before I give it to you. Yep, it's not that, it's .zip. Yeah, that's it there. Okay, right. So the URL you want, I'll paste in the chat window, is that. Oh, .zip. Sorry, .zip. Not .com, .zip. Boom, that one. Second one. That is the assets to work with in this project. And you'll see inside there, if I open it up a little bit, you will see a lot of pictures, some enemies, some weapons, a big game over picture, a player picture, and a player weapon picture, plus a few pieces of JSON. And that's all we need to make our game complete. That chunk of stuff right there is everything we need for our game. So I want to go ahead and use that straight away. So open your asset catalog and drag in the ping files, not the JSON files, just the ping files. So we've got the JSON file here, skip that, ping, 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 boom. Everything but the first one and last one can go into the asset catalog, basically, like that. And that's all the artwork we need for this game, basically, at this point. So, to get started, in our space game, we're going to start off really simple with a Starfield. Stars whizzing by on the screen, giving us a nice background to work with. Of course, you can use a picture if you want to, but I think a particle effect Starfield will look a lot nicer, more interesting for a start. So I'll go ahead and press Command N inside Xcode, then look for particles, and choose SpriteKit particle file, and press Next. For the template, you want to look for snow, choose that one, and then Next. And then call this thing Starfield.sks, with a capital S like that. Starfield.sks. That is the default built-in snow particle effect we get with Xcode, which it looks vaguely star-like, but I'm gonna make a few changes to make it more starry, more sort of space dusty. For example, we might say let's boost the birth rate up to 80, so it snows twice as hard. The maximum's 0, so it'll basically keep on making it as it goes. For a lifetime, I'll give it a really long life, like 50 or so. So it'll live a long, long time. Because some of these stars will go very, very slow in the background, and that way it's not going to disappear halfway through its movement. It'll always stay there. Range with 0. For position X, I'm going to enter 0 for X. So they all start at the same point. But then for Y, I'll use a massive variance, like 1,000 or so. Huge variance, probably more than we actually need. But a lot of it is the key. A lot of space there to just expand over time. For the angle, you can see it's sort of shooting downwards right now with a very, very fine cone. I'm going to change that so it fires at 180. Fires to the left, like we're flying left to right. Because the iPad is, of course, longer than it is tall. It'll look better going in that direction. And for range, I'll do 0, so they always go directly right to left, across the screen like that. For speed, we can provide some variance here. 80 is fine for the speed, but range, I'm going to say, is 79. So some will go very, very slowly indeed. Others will go quite fast. There's a lot of variation there. For acceleration, I'll use X0 and Y0 so they don't fall down. Because the Y minus 10 means pull them down from the screen as if gravity has infected them, which looks great sometimes, looks weird in space. Alpha's fine. The scale, I'm going to bring this way, way down. Like the scale 0.05. So they start tiny little space dots in the sky. And for range, I'll also do 0.05. So I'm not sure it's even visible on the stream anymore, but it's super fine, sort of space dust flying through the air. Some big bits space dust, some small bits space dust, but a lot of variation inside there, giving us our Starfield. Rotation is irrelevant because you can't really see these things spinning around, and color blend can stay as it is because it's just white space dust. Some of them, if you look really close, kind of look grey because they're so small, but it's still white, what we care about. So that's our entire Starfield particle effect done right there. It's taller than we need, but that's fine. It's fine to experiment later on if you want to, but that's enough for now. So I'll go to GameScene.Swift and put that into our game scene straight away. Let's make this take as much space as we can in our limited screen space. There we go. So in Did Move to View, we're going to write the code to create that Starfield and add it to our game scene so we can start seeing things straight away. We'll say if let particles is equal to an SK emitter node. Can I zoom in on the stars? This is just bigger dots. It's just white dots. Tell-in Turnbow, it's just a load of white dots. The file named is Starfield. Now, this is case sensitive, so make sure you get the capital S for using it in the file name, otherwise lowercase s. If we can get Starfield, fantastic. We'll do particles.position is CG point x 180. So way off the screen, like about 60 points off the screen. And y 0, like that. So it's off the screen, but centered vertically. We're also to say particles.z position or z position is -1. So it's behind the things in our game. And then add child particles. Okay. I'm going to try and build that and run it in the iPad Air simulator. For as much as I can while making this game, I'll use simulator. It's much easier to use. When we have to, we actually import core motion. That's when I'll switch across to using the main device. An actual iPad next to me. So hopefully we'll see a big and interesting space. Yeah, that failed. That's what's gone wrong already. Oh, there it is. Ah, it's rotated. Whoops, there we are. Boom. Loads of stars flying in. Let's try it again, this time not upside down. And you'll spot the obvious flaw with our particles. So, as you can see, the screen is basically empty, big grey space, and then, they fly in. And there's our space particles, all different dots and size and so forth. And when the screen finally fills up, it kind of looks pretty good. As a Starfield, it kind of works, right? It's like you get in the background of Star Trek, you get these Starfields flying by. But there's a problem, right? Because space doesn't start off empty. You know, if you're flying through space, there's no like 10 seconds of blackness first and stars appear out of nowhere. They're always there. Now what's happening is, of course, we create our emitter when our game starts and it starts firing particles straight away. But they haven't got time to reach across the screen before the screen's fully shown. Fortunately, we can fix that by going back to our code and saying particles dot advanced simulation time. And it takes a number of seconds. How many seconds do you want to fast forward to get the simulation where you want it to be? And I'll say 60 seconds, so 1 full minute. And with that in place, it'll make 60 seconds of particles first and fast forward them, all their movement and so forth. And this time now, with that, the screen should start, boom, filled with particles. So it looks like space immediately. Talon, I never use scene files. I just never use them. I find them confusing and weird. I do it all in code. So, we have our particles done. That's our background done nicely, and you can see that advancing really helps fill the screen with dots to begin with, which is fine. Let's go ahead and add the player to this. So I'm going to say, let player is an SK sprite node using the image named player, like that. And then we'll add that to our game scene by saying player.name is player, player.position, position.x is, I'm going to say, the frame, if you don't know in SpriteKit, measures its position from the middle. So this is a 1024 wide space, which means 0, 0 is in the middle. And because it's 1024 wide, minus 512 are left edge, and plus 512 are right edge, so half either way. Now, I don't want to say minus 512 plus some sort of amount. I'd rather say, actually, just give me the frame edge. So I'll just say frame.minx, which will be minus 512, plus some sort of offset, so the player isn't hanging off the screen. And I've tried it out, and I think 75 looks good for the sprite. It looks like the right sort of size. That means bring them in just slightly from the edge. Then player.z position is 1. Bring it above other things in our game. And add child player. I'll press Command R, build and run again. I'll drink some water in the meantime. There we go. There's our little player sprite. Flying through space. Bravely adventuring. Beautiful. Okay. Now, obviously, we want that player to collide with other things, so the whole game becomes more interesting. But we can't be lazy about this. We've got to be quite precise. Because we're going to have a player flying through space. We're going to have enemies flying through space. We'll have the player firing weapons at the enemies, and the enemies firing weapons at the player. And what we don't want to happen is for the player to collide with their own rockets, right? Otherwise, they'd kill themselves when they fire a bullet, right? And the same is true of the enemies hitting their own sort of lasers coming back the way. That'd be too confusing. So we've got to be really, really precise here and say, actually, there's 4 kinds of things we want to care about. Players, enemies, player weapons, and enemy weapons, and make them all individually collide and contact in different ways. So this is the correct way of doing good SpriteKit collision detection is like this. First, you make an enum that describes all your collision types. So I'll say enum collision type is a uint32. And you've got to be exactly precise about that, because that's what SpriteKit wants. It's like, yay, an exact sprite type, hurrah. So uint32 is fine for that. We're going to say there's a case for player, and the player example is 1. There's a case for the player weapon, and that's 2. There's a case for the enemy, and that's 4. And a case for the enemy weapon, and that's 8. So it'll work its way through 1, 2, 4, 8, then 16, 30, 64, and so forth. And this way we have distinct types of collisions we can say. We can say this thing, this is a player, and it collides with enemies and enemy weapons. Does not collide with player weapons, for example. We can be really, really precise in SpriteKit, and that's one of the amazing features about it. And that's why it's a uint32, rather than some more complicated type. It makes a really, really fast bit masking, as you'll see right now, in fact. So we can go ahead and give our player some physics. We're going to say player dot physics body equals an sk physics body with the texture. Now, I want to say the texture was going to be, boom, player dot texture. That's optional because, you know, lol. So I'll do a force unwrap on that one because we know it's got a texture. We made it with the texture already. And the size, we'll do player.texture again, force unwrap dot size. So the size of that thing. And that's a method which is really unswifty, but there you go. I might file Radar later on for that. So that's our physics body. Give us a pixel perfect collision detection around the player based on their texture. Next we'll say the player physics body has a category bit mask. This describes what kind of thing this is in the physics world. And for us, we can say, well, that is collision type dot player dot raw value. It's a player because that's what it is. It's a player's physics body. We can then say player dot physics body dot collision bit mask. And this thing is what it collides with, what it bounces off in physics space, what it actually bounces into. And I'm going to say, well, in this case, we're going to make it bounce into collision type dot enemy dot raw value or collision type dot enemy weapon dot raw value. Now this or here, a single pipe, not 2 pipes, it does a bitwise or. It'll add those together. And what will happen is you'll get enemy raw value, which is 4, and an open raw value, which is 8, and it adds them together. So you'll end up with 12. So it'll add them together. So it's a unique number it ends up with that you couldn't get any other way. Because if you had, say, 1 and 2 and 4, well, now you only have 7. Or 1, 2, 4 and 8, well, now you only have 15 and so forth. So it only adds up to a certain number in an exact combination of stuff, which is why you add up these doubles of bit masks around individual numbers. Question from Baz. Hi Baz, how you doing? Do I have an article on bit masks? So I use them in Hacking with Swift quite a lot. I think in the first 2 or 3 SpriteKit tutorials, we kind of skimp over them a little bit, saying, listen, just ignore them. and then we kind of dive in properly in one of the tutorials. I don't recall which one, but then it's in depth in there. I can probably find out for you real quick. I say, okay, let's go through bit masks really carefully and explain how they actually work. There you are. Project 26 is where it is. So yes, that's in there. So anyway, back over here. So we have this thing. What it bounces against. In this case, we're asking for exactly two things, which is the enemy bit mask and the enemy weapon. So our player collides with enemies and enemy weapons. The last bit mask we care about is player.physicsbody.contact_test bit mask. This is a third bit mask. So category bit mask describes what kind of thing this is. Collision bit mask describes what it bumps into in the physics engine. Contact test bit mask is what things, when they collide, do we want to be told about? Because mostly when this bounces off that, whatever, you don't care. You don't want to be told about it. Things just bounce around freely in the game. But sometimes when the player hits an enemy weapon, for example, that matters. You want to be told about that thing. There's an optimization here. Of course, you could very easily say, tell me about all collisions. I give it that the default. But there's a lot of extra work there because you're having to have these method callbacks for things you don't really care about. So contact test bit mask is separate. It means what you want to be told about when they collide. In this case, it's exactly the same thing. I'm going to write the same thing as before. I'll just copy and paste collision type enemy and collision type any weapon. So bounce off these things and tell me when you bounce off them. And be able to have these things as difference really, really important. For example, in that tutorial I linked Baz to a minute ago, we have a contact test bit mask of stuff and no collision bit mask. So you don't hit them when you run over them, but it does tell you to run over it. So you can get like power-ups, for example. It'll tell you, oh, you've touched this thing without you bouncing off the power-up, which would be weird, right? You want to go over it and just sort of hoover it up in sort of space style. Anyway, so I'll go ahead and press play now, and it should look the same, all being well. Let's find out. It's fallen off. My mistake. We've added physics now. And of course, when you add physics, it'll start falling down because gravity pulling down. It's the fault of Earth-like gravity, 9.8 meters a second. So you want to get rid of that. We're going to say player.physicsbody dot is dynamic is false. So don't be pushed around by gravity. Let's find out if that's any better. Much better. Okay, great. So now our player kind of works. So on the screen, they've got a physics body. You can't see it, of course. There's a wonderful option I recommend you enable in the game view controller when you're sort of working things out. If you say view.showsPhysics equals true, now you'll struggle to see it on my screen because it's really tiny. But on your screen, you'll see it draws a very, very faint blue line around physics objects here. So in this case, a little line around the object here, it's super small, but it shows you it's on a really good pixel cutout of the rocket here, which is fantastic. Anyway, so it works. Now, obviously, this game does work, but it's very boring. The players are sort of flying through space by themselves. We really want to add some enemies here that do things on the screen and interact and fire weapons or whatever. Otherwise, it's a very dull game indeed. Now, I could just go in hard code, wait 1 second, create an enemy, fly an enemy, wait another second, whatever. But that's not fun, right? That's not a scalable solution. We want a scalable solution we can expand to have level 2, level 3, level 4, level 5, level 6. And that's where our use of Codable is going to come in. Because we're going to go ahead and use these two JSON files I made earlier. I'll drag them into my project now. Enemy types and waves.json. Drag those into here. And they describe how things look. So if I look at enemy types.json, you'll see there's enemy 1 has a shield of 1, a speed of 600, and a power-up chance of 10. So every 10 you kill, you're going to get 1 power-up probably. Enemy 2 is stronger but slower, more higher chance of power-ups. Enemy 3, really strong, much slower, very high chance of power-ups. Kill 2, get 1 power-up. So that's the enemy types we can work with. There's also waves.json, which describes the way we're going to create waves. So we're going to say there's a small wave that creates at position 0 with some x offset and move straight. 3 ships are in that wave. There's a medium wave which creates 1, 2, 3, 4, 5, 6 ships at various positions, not moving straight anymore, so not straight at you, but moving around the screen. And there's a large wave which has many ships being made, some moving straight, some not moving straight. And at the end is a random wave where there's no enemies at all, so we'll make them appear randomly on the screen at that point, flying in. So we've got 4 different kinds of waves of all different shapes and sizes, movements and positions and whatever. And we're going to try and use that to create our enemies. So those things are both JSON right now. We want to load them into our game. So we're going to say Command N, make a new Swift file. I'll call this thing an enemy type. This will store exactly one instance from our enemy types JSON. I'll change this foundation to be SpriteKit so we can do things more nicely. And we'll say there's a struct enemy type, which is Codable. Now this thing, it has name, shields, speed, and power-up chance. So I'll copy that into here by saying var name string, var shields, int, var speed, a CG float, and var power up chance is an int. Now this is CG float because speeds in SpriteKit are stored using CG float. So we can't use a double or an int for that. It's got to be a CG float, otherwise you've got to do typecasting later on, which no one wants to do. So that'll store one kind of enemy in our game. We also want to load this waves thing, how we handle waves of enemies coming at the screen at the same time. This requires another new file. So I'll press Command N and choose Swift file. I'll call this thing wave.swift. This has, in our waves file, it has a name, then an array of enemies, and each enemy has position, X offset, and move straight, boolean or true or false. So we can say, again, import SpriteKit. Struct wave conforms to Codable. Struct wave enemy, that's the array inside this thing, also Codable. That has a position int, has an X offset CG float, and a move, come on, you can do it, var move straight is a bool. Then outside of that we can say that var name string and var enemies is an array of wave enemy. Okay, so those are 2 structures we need to try and hold all that JSON. Now I've done it before in the Inner Peace project a few weeks ago. When I'm loading JSON from a bundle, usually more than once, but even once sometimes, I hate doing it by hand. It really annoys me to do it by hand. It's like, find this thing in the bundle, load it into a data, decode the data. It's a lot of hassle right now. We're doing it twice. I'm going to write all that code twice, which would just wind me up, quite frankly. I much prefer to do an extension on something like bundle that lets me decode things straight from a bundle. So I make a new file in here, new Swift file called bundle-decoding. I'm going to say in here, extension on bundle. There's a new method called decode, which takes a t where t is some kind of decodable. We're going to ask folks to specify a type here. We'll do type is a t.type. From a file, a string returns a t. Question from Baz, any reason variables or constants here? You're absolutely right. I do that every time, and I don't know why. It's like I know better. I know absolutely better and still do variables every single time. I don't know why. These should all be let. There's no reason for the variable here at all. I'm just so stuck in my ways. No, it should barf if it isn't found in the JSON, and regardless whether it's proper variable or constant. You have to use optionals to get that otherwise. Yeah, constants are way better here. I'm just stuck in my ways, which is a bad thing. Anyway, decode some sort of decodable thing from a file name in our bundle. So we're going to say first, guard let URL is self.url for resource, our file name, with extension nil. No, file name, there we go. With extension nil, else, fatal error, failed to locate string interpolation file in bundle. Boom. Then guard let data is try data contents of that URL, else, fatal error, failed to load file from bundle. So we've got the URL for it, we've now got the data. We can now try and decode that by saying let decoder equals a JSON decoder. Guard let loaded is try decoder.decode. T.self, whatever was passed in by the user or by us later on, from that data. If that fails, fatal error, failed to decode file from bundle. Boom, like that. And if all that succeeded, hurrah, we can finally do return loaded. And this will let us decode anything from any file in our bundle, as long as the thing we're decoding is JSON and decodable. So I'm going to go back to game scene.swift. We can go ahead and start using that. We can say for our game scene, there is a new property called waves, which is bundle.main.decode. It's an array of waves.self from waves.json. Then let enemy types is bundle.main.decode array of enemy type .self from enemy types.json. Like that. Boom. Great. Use a do catch. With the JSON decoding, you mean, Baz? Use a do catch. I wouldn't use do catch for that. I'd use fatal error. Personally, but there you go. That's just me. So this will give us now an array of waves and an array of enemy types in our two properties. So we can start using those straight away. But we also need a way of describing enemies. Because if I just say on the screen there's a sprite node with an enemy, I can't do much with that, right? We can't track what kind of weapon it should have. We can't make it fire stuff. We can't give it some shields. We can't do anything useful with that, right? So, folks who watch me regularly on Sundays will know I use fatal error quite a lot. In this instance, I would never ever log the error. I just wouldn't do it because you're decoding JSON from your bundle, right? It's either there and correct or it's not there, it's wrong. I would personally have tests to check my JSON is correct. It loads JSON every time and decodes it in a test. So I would never ever even consider shipping an app with bad JSON because it's not possible, right? Now, because this thing's attached to bundle.main, that's why I feel safe. If this were a generalized JSON decoding thing, I'd be more careful because, can I go back? Yes, I can. I'd be way more careful because obviously you're loading remote JSON, it could be wrong, you want to log that very carefully and handle it, do catch, whatever. This is JSON I've hard-coded and checked in my app bundle. It should never be wrong. My test would catch that it was wrong immediately and force it to be corrected. It wouldn't even be checked. You couldn't even check into the code. It would refuse to get checked in because it failed tests. So I have no qualms at all using fatal error in this particular method. It makes it much easier to read as well. So anyway, I was saying we can't just use sprite nodes here for our enemies because we can't have things like firing methods. We can't have shield types attached to it. It's not very useful. So we're going to create a custom subclass of SK Sprite node so we can have these bonus methods to do more interesting work for us. So, assuming Jason's finished with that file, if not, take a screenshot. It's much easier. You know, Command Shift 3 while you can. Okay, I'm done with that, Jason. Let's go ahead to the next file again. So I'm going to make a new enemy node type, subclassing SK Sprite node. So I'll press Command N, choose Cocoa Touch class, subclass SK Sprite node, and call this thing enemy node. And save to my desktop. It'll error straight away because it imports UIKit, not SpriteKit. So thanks for that, Xcode. That'll fix it. Now, what we want to do is give this thing some information to work with, right? Because we want to say, here is your shield level. Here's when you last fired your weapon. Here is when what kind of enemy you are, for example. All these things will be stored inside the enemy class, neatly hived away, right? So we're going to say var type is some sort of enemy type. So you're a type 1, you're a type 3, and so forth. We'll also say var last fire time is a double of 0. So it's never fired its weapon. This will track the last time every enemy fired their weapon. Otherwise it might fire all the time, which would be a bit too hard even for me in this game. So make it irregularly firing would be nice. We'll also say var shields is going to be some sort of integer. Like that. So we can say you've got shields level 1, 3, or 5. So like we have in our enemy type.swift. JSON here. So 1, 3, and 5 shields here. Anyway. We need to give our enemy node an initializer that works well. So we'll say init with the type of an enemy type, a start position, which is a CG point, an X offset, which is a CG float, and whether it should move straight or not. Bool. Now, as soon as we add a custom initializer, we have to also add the hideous coder one as well. So we'll say required init nonsense coder stuff. This, again, fatal error, lol no. We don't support SpriteKit SKS files in this game. It's regular code, nothing at all. So as you can see, we have initializer takes an enemy type, your type 1. The start position is where it should be placed in the game scene, so like here in the game scene. But the X offset is useful because we can push it back in the game. Because one of those options, the random option, is going to create enemies at all different positions vertically. But rather than have like a wall of enemies fly at you, it's going to push some back way off the screen, like at 2000, 3000, 4000 X. So they come and fly in sort of like flurries rather than one big wall of fighters at the same time. Hi Michele, how are you doing? Of course, go and rewind and follow along. And move straight, like I said already, they're either going to move straight at you or they'll come at a curve at you, but either way they'll move around the screen somehow. So, we want to go ahead and for the initializer, we'll say self.type is that type. Our shields, our current shields value, how many hits it takes to destroy this thing, is going to be the default shields for our type. Of course, it's variable, so it'll go down over time. We're going to get a texture from this thing by doing sk texture using image named, that one, type.name. And the reason for that is because the designated initializer of sprite nodes is with a texture. So we can now say super.init, passing in that texture. Here it is. Boom. That texture. Or the color property there as well, which I've missed out by accident. Color.white. And size is our texture.size. Like that. So that'll create the main sprite node using our current sprite. We also want to assign the default physics body, so it'll have the right shape for this enemy type that was made. So we'll say physics body is equal to sk physics body with the texture of that texture is made. No more not required, hurrah. And texture.size. We'll also give it the physics body we discussed earlier. So we'll say physics body dot category bit mask. Now this is the enemy here. So we're going to say collision types dot enemy dot raw value. Mark it this thing as an enemy. And physics body question mark dot collision bit mask. What it should bump against in the game is going to be collision type dot player dot raw value or collision type dot player weapon dot raw value. So bounce off the player or the player's weapon. And physics body dot contact this bit mask. What to tell us about is also going to be equal to those things. So I'll copy and paste that again. Boom. For the name's going to be this enemy. Enemy. Great. Our position is going to be CG point, x of start position.x plus the x offset to push off the screen if we need to, and the y being start position.y. Question from, who's this over here? Lima 432122. I don't use Discord. I don't like Discord at all. There's a Slack. Join the Slack. The Slack's much nicer. I don't have Discord. It just drains my MacBook CPU, which really, really winds me up. Anyway, so that creates our enemy spaceship straight away. We're going to add another method, though, which will decide how this thing should move across the screen. And movement in SpriteKit is wonderfully simple. I love the way it works. If you make a Bezier path, like move from A to B or move from A to B via C, you can make it follow that path. And it'll even orient itself to the path, so it will rotate the thing as it moves around the screen. So it'll look really, really nice, sort of out of the box. So I'll say func configure movement. Should it move straight or not is a bool. The path is going to be a UI Bezier path. We're going to start by saying path.move2.0, start to the 0, 0, x and y coordinates. This is because you can make these things relative or absolute, and I prefer relative, as you'll see. If we're down to move straight, then path.addLine to CG point x, something way off screen. We want this thing to fly way, way off screen. It's definitely going to disappear. Because remember, the x offset might make them start way off to the right of the screen, so it'll make them fly way off to the left of the screen. So like minus 10,000 or so. So it'll definitely go totally off screen, guaranteed. And y will be, oops, sorry, not that one. Go away. Let's try it again. Y is 0. So don't change your y, just fly straight ahead, but go way, way off screen to the left. That's the whole thing to move straight. Else, if we're not moving straight, we're going to add a curve using control points. We'll say path.addCurve2. This one's a CG point, so I'll say CG point is going to be x minus 3500, y 0. Control point 1, I'm going to say is CG point x 0, and y will be minus position.y times 4. And control point 2, I'm going to use CG point x minus 1000, y is minus position.y. And these numbers here are entirely arbitrary. I have noodled around for a good 10 minutes deciding the best sort of curve I like to make my ships look nice on the screen. It's a Bezier curve. Draw them however you want, right? You can make them flip around and do circles where you want to. It's down to you. This is enough for me in this game. You get a bit of a curve to their movement. But they are entirely arbitrary. There's no magic maths here. I've just typed things in until I was happy. Try and error, the old-fashioned way. So that's our Bezier curve to move along. We now want to say that movement is skaction.follow. Follow some sort of path over time. And there are a few options for this one here. I want to choose the one with speed and orient the path. So I'll choose this one here. And the path is going to be path.cgPath. As offset is true, that's offset to the current position of the thing, which is why we start from .0, start from your current location. Orient path will be true. That means turn around, you're always facing forwards on the path. And for the speed, I'm going to say type.speed. So go as fast as this craft's designed to go. However we design this craft to go, that's how fast it should go. So the little ones go fast and the big ones go slow. That move across the screen from right edge to left edge smoothly, which is great. When it gets across the left edge, we want to destroy it. Ditch it entirely. So we'll say let sequence equals skaction.sequence sequence an array of that movement plus dot remove from parent. So destroy the thing as soon as its movement's finished. And finally, run that sequence. So as soon as it's made, start running that sequence. And that's enough for our movement. So we can just go ahead and call that from our initializer by saying configure movement, passing in the move straight thing we got. Boom. So that hopefully is almost enough to make our enemies actually work. We've created the waves, we've created the enemy types, we've got an enemy node around it now. All that's left is to actually create these waves as needed in the game. And the way it's going to work is we're going to say, as the game goes round, it'll say how many enemies are currently on the screen. If the answer is 0, it'll create the next wave, and the next wave, and the next wave, until it's gone through all 4 waves, and then it'll restart, increasing level by 1. And in my game, level changes mean no difference at all, but in yours you might say, okay, make them move faster now, so the game gets harder and harder and harder, for example. Anyway, we need to add some properties here to our game scene to make all this work. We've got to say things like, is the player still alive? Because they could be dead, in which case you don't want to make any more enemies. What wave number are we on? Is it the first wave, second wave, third, or the random wave? What level number are we on? And where do we want to place enemies? Because you can see I've referenced in my wave.swift, my wave.json.swift, sorry, there's like position 6, position 5, position 2. So you can make formations of enemy fighters flying out. Make formations like, V's and, W's, whatever you want to, flying at the screen, which looks really cool. But we've got to define what those are. What is position 2? And in our game, this is pretty straightforward because we know our X coordinate, the edge of the screen, make them off that somewhere, plus some X offset. What matters is the Y number. How far up or down should we make this particular thing? Because if we say, make it 0, 0, it'll be in the middle, and then up by 50, right by 50, it'll get towards the back right of the first one. Then again, make a nice line, and below it, make a nice V shape. So you can make some really nice shapes with almost no code here. So we're going to add some properties for that. We'll say, is the player still alive? Var is player alive? True by default, they're alive. Otherwise, it'd be a very hard game. Then var level number is 0, so start off at the first level. And wave number is also 0. So we're level 0, wave 0. And last, we have to try and figure out the Y coordinates we want to create stuff with. And I don't want this to be random, because random means you can't make nice formations. If we use an actual structured array of these things, then we can make formations really nicely and easily. So I'm going to say let positions equals an array of a call to stride. I love stride. Stride's like a for loop, which goes from to number to another number, using some jump each time. So I'll say stride from through by. I'll say stride from minus 320 to plus 320 by 80. That's my stride. Now, you should know that we've made a 768 high screen. So this means it'll only use about 640 or so of that. Minus 320 to the plus 320. So there's a bit of space at the top and bottom. You can go a bit further if you really wanted to. In this case, it's probably fine. So that's our total array of Y positions do we want to create fighters at. We can now say, write a function that creates a single wave of enemies. We'll say func create wave. Wave. Come on, you can do it. Wave. There we go. Boom. And this is going to do a few things. First, it's going to say, bluntly, is the player still alive? If the player isn't alive, don't bother creating more waves, because if they've died, give up the ghost, no point carrying on the game. So we'll say, guard, is player alive, else return. Like that. So don't even make any enemies once the player's dead. Game's over. We can now say, are we at the limit of our waves? Because there's as you see in our waves.json, there's only a few of them here. There's a small one, there's a medium one, there's a large one, then a random one. So it's going to go small, medium, large, random, small, medium, large, random, small, medium, large, random, again and again and again. And as the level gets higher, in theory, it could make our enemies appear faster and faster, or move faster and faster. In this instance, though, we'll keep it nice and simple. We're going to say if wave number is equal to waves.count, then level number plus equals 1, go to the next level, and wave number is 0. Go round from the beginning again, hopefully this time harder. We can now read the current wave we're on. We can say let current wave equals waves of our wave number. So it'll say, oh, you're on wave 0. Fine. Here's the enemies to create in that current wave constant. And we can add 1 to wave number so it's different next time. Now, the next job, the real job here is to try and create some enemies. So you can see more clearly things flying across the screen. Now, you've seen I have 3 enemy types, enemy 1, 2, and 3. But the enemy 3s are harder. They're slower, but also, they have more hit points behind them. They have like 5 shields, for example. So we don't want to throw those at the player straight away. We want to make some easy ones first, then some middling ones, then some harder ones. And a nice easy way of doing that is by saying, make a random enemy type between 0, the first enemy, and some other value. Now initially, that should be 0 and 0, so you always get a basic enemy. And then 0 and 1, so it could be the basic, could be the middle enemy. And then 0 and 2, could be basic, could be middle, could be hard. But it changes over time. So we're going to say, let maximum enemy type be equal to the minimum of enemy types.count or level number plus 1. And let enemy type be equal to int.random in 0 up to less than maximum enemy type. So we know enemy types.count will be 3 because that's what it adds up to. If our level number is also 3, then the minimum of 3 and 3 will be 3. So we'll get a random number between 0 up to less than 3. So 0, 1, and 2. So it'll show small, middle, and large enemies. But if our level number is lower than 3, so if it's 1, for example, we'll end up only using a smaller set of enemies. The smaller middle one, for example, not the large one. Or even lower, just the small one. So this helps us mix the game up a little bit, so it isn't just like, here's all the enemies straight away. It's a real flexibility of stuff appearing on the screen. That's the enemy to create down there. We can now say, let enemy offset x be a CG float equal to 100. And that thing is how far we're going to push spaceships back to make our formations. So this means if the front one's here, the next two will be 100 point behind, next 100 point behind that, 100 point behind that, and so forth. So you get a nice V shape of ships on the screen. It looks much nicer. So that's how much we're going to push ships back when we want to. We also want to say, let enemy start X is 600. This is the position they're going to start on the screen when they're first made, by default, if there's no enemy offset. That means just off the screen. Remember, our thing goes from minus 512 through to plus 512, plus some amount of extra points there because the ship will have its own space. So, it's going to be about 50 points off screen, more or less, depending on the size of the craft. Is that number there? Oops. Now we can say the important stuff. We can say, if we are currently out of enemies, if there are no enemies in our wave, so it's that last wave where there's no enemies, that means it's a random wave. Just make them wherever you want to. So we'll say, if current wave, dot enemies, a question from Ethan Booker, where can I find private streams? It's YouTube. They're all on YouTube. They're all on the Swift on Sundays. There's like 10 of them so far in the last sort of few months. They're all there. Go check it out. If current wave dot enemies dot is empty. So if in one of these random waves, there's no enemies currently in our wave, then we're going to shuffle up all our positions and position them around that space. So it could be in the middle, then top, then bottom, then wherever, all over the place. So we'll do this. For index position in positions dot shuffled dot enumerated. Boom. Mix them up, then enumerate them. We can say let enemy equals enemy node. For the type, we can say enemy types is enemy type, whatever's chosen for this wave so far. The start position is going to be CG point, X enemy start X, Y our position, X offset will be X offset, our enemy X offset, there, times some sort of offset. Now, in this game, when it's a random one, literally trial and error again, I found that pushing them back with enough space gives folks a good chance to move around and space them and shoot them more accurately. Of course, you can just avoid all the ships to survive. That's not fun. You want to shoot the ships here. So through trial and error, I found the best approach here is to say a CG float of index times 3. So when it's in random mode, push back the enemy offset to be much, much bigger. So not 100 space anymore, it could be 300 in space instead. So it's much bigger space between ships instead. And finally, move straight is true. When it's random mode, just space them fly towards the end of the screen, like empty things. if we have predefined enemies, so if the enemies is not empty, then we're going to say, let's scroll down a little bit, we're going to say for enemy in current wave dot enemies, that node is a new enemy node with the type of enemy types, enemy type, start position of CG point, X enemy start X, Y is going to be positions, enemy dot position, X offset, enemy offset X times enemy dot X offset, and move straight is enemy dot move straight. So use type we're choosing for this whole wave. Start position is going to say make it have off screen slightly backed up by its position in the Y. The offset, we're going to push this thing back by whatever was defined in the JSON. So if it's offset 1, it'll do 100 and push it back 100 pixels, or 10, 1,000 pixels or similar. And move straight is whatever the enemy is designed to move in the JSON again. Let JSON decide how the game should respond. Regardless of that stuff, we're going to say add child enemy here and here. So no matter how it's moving in the game, we want to, no matter how it's moving in the game, we want to add them to our game scene, so it'll just figure it out. And that's most of the work required to make our game come together. Realistically, it's actually pretty easy from here on in, because now we're what we'll call create wave at sensible times in our game. So we have, or at least had, an update method. It's gone away. I'll make a new one. Update. There we go. This is called before the game scene's drawn, every time it's going to be drawn. So it's called 60 times second or 120 times second, depending on the device you have. So it's going to update regularly. What do you want to do? And we're going to put a few rules in here to make sure that we remove things correctly. Now, as you've seen, we remove enemies automatically, which is fine. We're also going to be more aggressive and trim things like our own lasers and enemy lasers and anything else. If they're off screen, we're going to get rid of them straight away. So we'll say for child in children, if child.frame.maxx is less than 0, so if this thing's at least halfway onto the screen, and if not frame.intersects child.frame, so if we are not overlapping, as i.e. we're not visible on the game scene somewhere, then child.remove from parent. Ditch the thing immediately. Now, this is really, really helpful. If we had just saying, does a child frame intersect our game scene frame, then it'd be destroyed immediately because it starts off screen. So it doesn't overlap immediately, so it'll be destroyed straight away. By saying, are we at least halfway onto the screen, at least, or more than that, of course, now it makes sense. If we're not intersecting the main screen, destroy it. Otherwise, you destroy them straight away. It's obviously a bad idea. After that loop, we're going to say let active enemies equals all our children dot compact map with the transform $0 as question mark enemy node. And this will give us back an array of all enemy nodes in our current game. And we can say now if active enemies dot is empty, create wave. So only call create wave when there are no more enemies currently on the screen. Now hopefully they will all, if I press command R, minus gravity, which I haven't looked at yet, they should all at least come on the screen, all being well. Let's find out. There we go. So they're flying in the screen, looking a bit odd perhaps because they're flying off and dying straight away, but in theory it kind of works, right? We can fix that by just killing gravity. It is overrated. We're going to say in did move to view physics world dot gravity is 0 because we're in space, of course. Now there we go. So we now have enemy fighters flying around. You can see them curving around a little bit and changing their angles and so forth. There's little shapes flying in. You can see now they have formations and stuff. As it colliding badly. Here's a random one. Place that across the screen nicely. And it repeats again. A nice wide formation. Oh, level 2 now. Different kinds of ships. Look at that. Nice formation again. Uh-oh, I'm doomed. Okay. This is kind of coming together, right? We have waves of enemies coming in, different kinds of enemies. So you can see that's level 2 ship right now. They all move nicely. The Bezier curve looks good. Here's level 3 enemies, the big slow ones flying in. It's actually working. So we're about 2/3 of the way through the project, I guess. This is a good time for me to remind you, please like this video. I mean, I'm giving up my Sunday evenings for you, free of charge. Go ahead and press the like button because it helps other folks discover these videos. YouTube ranks these videos higher based on the number of likes. So leave comments saying you liked it, or a like would be very much appreciated. It does help other folks find the video. Thank you very much. I'm sure the number of likes are shooting up right now, he says, in full of hope. Anyway, so this game's kind of coming together, which is great. Let's go to the next step. I want to make our enemy fighters shoot stuff. So I'm going to kill Xcode, like that. I'm going to say in our enemy type, enemy node, what's enemy node? Here it is, hiding up there. It's reorganized slightly, there we go, enemy node. We'll add a new method in here, which is func fire. And it'll tell us firing weapons on the screen so they can shoot our player as they're playing. Yay, like just jumped. Good, I should hope so. These things take a lot of work to prepare and deliver, so I'm glad you folks do take the time to at least like the video and leave a comment saying you loved it. Anyway, so we're going to add an extra method in here saying fire. I'm going to say func fire. So our enemies can fire at their own time whenever they want to. Now, every enemy has a name like enemy 1, enemy 2, enemy 3, and they match the assets in our asset catalog. So you'll see enemy 1 is here, enemy 2 is here, and enemy 3 is here. And they have their own weapon too. So that's enemy 1, weapon, little green laser, enemy 2 is a bigger blue laser, enemy 3 is a sort of cross thing going on. They have their own different kinds of weapon, but they're named after the enemy name. So enemy 1 has enemy 1 weapon, enemy 2 has enemy 2 weapon, and so forth. So inside fire we can say, let weapon type be equal to type.name, followed by weapon. So it's enemy 1, weapon, and so forth. We now make a sprite node just for that weapon by saying, let weapon be equal to sk sprite node with the image named weapon type. Boom. Weapon.name is going to be enemy weapon, so we can track what's hit what later on. Weapon position is going to be our position, so it fires from the enemy outwards. Weapon.z rotation, what angle it's pointed at is going to be our z rotation. Now keep in mind, some of our ships don't fly straight, they fly at a curve. So if they fire and they're pointing down the way, the bullet should also fire at pointing down the way like that. Oops, sorry, equals that. Boom. Then, the important stuff, physics bodies. We're going to say this thing has a physics body. Generic some. Thank you very much. It's very generous of you. Weapon.physicsBody has an SK physics body. And for this, I'm not going to do pixel perfect detection. There's no point. There'll be lots of bullets flying on the screen and very quickly as well. There's just no point. We're going to use a rectangle for the bullets. So we're going to say rectangle of weapon.size. It's much faster to do rectangle physics than it is to do pixel perfect physics. Then weapon dot physics body question mark dot category bit mask. What is this thing? It is a collision type dot enemy weapon dot raw value. Boom. Then weapon dot physics body dot collision bit mask is collision type dot what do any weapons bounce against? Well, the answer is just players really. Dot raw value. And weapon physics body contact test bit map mask. What tells us about the collisions we care about? And the answer is no bit mask. There we go. Is a collision type dot player dot raw value. See here's what it bounces off. Now we're going to make one extra change here, and this change really matters because Box 2D, the physics system underneath SpriteKit, really cares about accuracy of stuff, which means if you push a big heavy thing like as hard as you can, it'll move a small amount. If you push a super light thing as hard, it'll go much further. Now, by default, it calculates the mass and therefore the density of its objects based on the size of the object. It'll say, oh, this is quite a big object. Let's have a lot of mass behind it, basically on its size alone. And what this will mean is we'll have our weapons, which are all lasers, moving at different speeds in the game. All this big laser is slightly slow, this tiny laser is much, much faster, which is weird. So we don't want to do that. We want to say they all have the same mass, which is basically a nil mass almost, because it's light, right? Yow, it flies out super fast. So we'll say weapon dot physics body question mark dot mass is 0.001. So very, very low mass indeed, but the same for all our weapon types. They'll all fly out at the same speed, regardless of how big the sprite actually is. Now for the important part. I think it's explained on my site in more detail, I think, in my knowledge base, which is now, by the way, fully up to date for Swift 5. We have to try and push this weapon in the right direction, because we need to use physics here so it collides with our player correctly. We've got to try and push it in its direction. So if it's pointing down the way, like this, or across the way slightly, or whatever, we're going to push it in that direction with an impulse. And this requires a bit of mathematics. We've got to say some sort of speed. I'm going to say CG float 1, but it's a nice constant here, so you can modify speed later on if you want to. We then want to factor in our rotation. But the problem is, our rotation is offset by 90 degrees, because SpriteKit's idea of 0 is pointing to the right. Whereas if you look at my assets, our idea of 0 is pointing up. You know, which I personally consider 0, right? SpriteKit does not. It thinks like 3 o'clock is 0. So we've got to offset that. Now in SpriteKit and UIKit, we measure angles in radians, not degrees. So we've got to take half of pi radians is 90 degrees. And I mean, I can't really explain that. It just is. Half of pi radians is 90 degrees. That's what it is. That's what radian is, right? So I'll say let adjusted rotation be equal to our z rotation plus CG float dot pi divided by 2. So move this thing round so it's pointing in our idea of 0. Now comes the important part, the fundamental mathematical formula to figure out the x and y velocity of something based on its angle. We're going to say, let delta x, the movement to the x, be our speed multiplied by the cosine of our adjusted rotation. And then our dy, our delta y, be our speed multiplied by the sine of our adjusted rotation. And that is just how the maths works, quite frankly. The cosine and sine of that rotation will give you the x and y position you want to move at on a circle. So we now say weapon dot physics body question mark dot apply impulse. Give this thing a push. Takes a vector, so I'll do CG vector. Dx is dx, dy is dy. So push it in that direction. By that amount, by however much speed we have multiplied into that thing. So it'll mean the bullet will fly off in the direction the enemy was facing when they fired their weapon, which, you know, would make sense in the game, right? And now, we have just got to try and call that at some point in our game. How many have time? About an hour and 10 minutes, not bad. We have to try and call that from our game. So I'm going to go ahead and find in GameScene.swift, we have an update method here. We're going to add some code here, which is, I'll put it below, actually, put it at the end, here. For enemy in active enemies, go through all enemies we have. And first we'll make sure this thing's actually visible on the screen, because we don't want them firing if they're off the screen. That just looks weird. So we'll say guard frame.intersects enemy.frame. Else continue. So if we are on screen, we're going to use them. Otherwise, go to the next enemy, the next one. We find one that is on screen. And if the enemy's last fire time property plus 1 second is less than our current game time, that's being passed in to the other method by SpriteKit, saying here's the current game time. So you can say, has at least 1 second passed since they fired, by doing this comparison here. And if so, we'll make enemy.lastFireTime equal to our current time, saying they fired now, or tried to fire now. I say try to fire now, because we don't want them always to fire. It'd be too predictable. We want to make it a bit uncertain when they're going to fire. We're going to say, if int.random in 0 through 6. So a 1 in 7 chance of them firing each time. Again, this is about trial and error. I tried things out, and it seemed to work quite nicely for this. So if we're in 0, 6 is 0, then enemy.fire. Go ahead and fire now. I will try running that. Oh, question from Mr. H. Enkura. Why don't you use case where in the for loop with nested if? Oh, you mean like for enemy at rounds where enemy at last fire time? You mean like that kind of thing? I guess. If that's what you mean, let me know. Line up to 3. Oh, you don't mean that at all. So what you mean having it here? Like that? Like that? Well, like that. Is that what you mean? I'm guessing here. Need to be more specific with your question. John Nyquist, thank you very much. It's very kind. I'm glad you're enjoying 100 Days of Swift. I press Command R while Mr. H. Enkura is thinking about his question slightly more. Hopefully we'll see them firing now. Let's find out. Some enemies. Come on, shoot me. Is anyone going to shoot? No one's going to shoot. So it could be a bug. Or it could be bad randomness. I'm guessing bug. Did I forget some code, perhaps? No one's firing. Right, I assume it's gone wrong somewhere. Let's find out. Enemy fire. That looks good to me. That looks good. Child. Where's my firing code? Enemy node. Who didn't call add on the bullets? Add child weapon. Yes. Gonna have problems as you do that. Let's try again. You know, shoot. Oh, someone tried to fire there. Oh, it kind of worked. It looked a bit wrong, but it kind of worked. Let it go. Oh, yeah, so it's almost working. Not quite right. I think I probably muffed up something along the way. Yes to reduce the nested if. Yeah, so the for in where, I think I used it a lot when I first came to Swift, and I've reduced over time because, and I guess it is Swifty, but I'm not seeing it frequently enough in other folks' code to make me think they're comfortable with it. I think the standard is not to use it. I think folks prefer not to use it by default, and only if someone says, "Oh yeah, we can write this in a much more Swifty way here," only then do they start actually using it. So I'm dubious personally as to whether it's a good idea or not. So the jury's out. I say I used to use it. Nowadays I tend not to because it's just a bit, not ideal, bluntly. So it's a taste of it's a matter of taste, right? If you like it, you use it, or you want to, it's fine. So our weapon isn't quite right, and I wonder why not. It looks like it should be right. Rotation to rotation, physics body, la la la. It kind of looks right, but I think I've got the angle slightly off in my code, because if you look at the thing, it's a bit wonky when it fires. I might try and make them fire more often, perhaps so you can see it fire more frequently, because otherwise it'd be a long time. But there you are, he fired. He's stuck. Excellent. Oh, sorry, I know what I've done wrong. Whoops. So we've made a mistake here. I made a mistake here. In my rush to fix our bug, I made a mistake by calling add child weapon, which is a bad idea. Don't do that. Because that adds the weapon to the spaceship. As the spaceship carries on turning, the laser is attached to the spaceship still, which is a bad idea. You don't want to do that. You want to attach that to the parent of the spaceship by saying parent ? .add child. And hopefully that will look significantly better. Let's find out. You know, fire. Oh, he fired. Didn't go anywhere, but he fired something at least. It's a step forward. Okay, so not moving anymore. So I made a different mistake, perhaps. But at least they are at least vaguely working. You're going to crash into him. Fantastic. Yeah, okay, it's at least the lasers aren't going weird anymore, which is better. So I made a different error. Question is, what error did I make now? You look fine. The speed's probably fine. Oh, I can go faster, perhaps. That could be the issue. Let's find out. Make that speed really, really big. Let's find out if that's going to be the problem. Come on. The matrix is indeed freezing bullets. Yeah, they are staying still. I made a mistake somewhere there. So they are trying to fire, and then the bullets are staying still, which is not ideal. I may have muffed up the collision bit masks. No, they look correct. Any weapon. Let's move that up to the top where it should be, really. That's otherwise fine. Position's fine, rotation's fine, physics body's fine, weapon size, mass is fine, speed is irrelevant, didn't do anything, which I think 1 is probably enough, quite frankly. The CV12 plus 5 divided by 2, speed times cost, rotation is fine, this rotation is fine, DXY. I think it's basically fine. I'm missing something else. I've obviously screwed something else up by accident. I'm just not terribly sure what. So, weapon type, sprite node's fine, name's fine, position's fine, rotation's fine. Agile weapon. That all looks fine to me, you know. I think we could colliding against something. I was not sure what it could be colliding against. Let's have a look. Let's go to game scene.swift so I can fix this bug real fast. I'll make it always fire temporarily so that we can just see more accurately when it is not working. I will always fire. I'll always fire. Let's remove that just in case that's causing issues. It shouldn't, but just in case it was causing issues. And then let's remove the collision bit mask just in case that's causing issues as well. So we've got a 0 collision thing. Always collide with nothing at all, basically. You know, build for me. Oh, there you go. That's slightly better. And no more Of course, yeah, we're not deleting the strips anymore, are we? Let's put the strip back in again. Which was, where's that? It is this one here. Boom. Let's try again. So we're slightly better off. That's good. Let's get rid of the other thing again. The add child made the difference, did it? Okay. Oh, I was trying to apply a force and it wasn't in the game scene, wasn't I? Presumably. Yes, that'll be it. That'll be it. I had my code ordered incorrectly. I had the add child here towards the end of the method. So I was having it after giving it a push. So it wasn't having physics applied to it, I expect. So that is the problem right there, I expect. If I put it back to as it was... Scarlet Butt, how I debug issues in reality versus how I debug them on a live stream on YouTube where I can't edit the debugging is very different, let me assure you. Anyway, the ships fly out, they fire some more. You can see they bounce off us now, which is quite weird, but it actually shows it's working at least. So lasers are flying out correctly now, which is great. Okay, fantastic. So, this is kind of working actually. So that is now firing weapons correctly. We now want to fire back. So when we tap the screen, we want to fire back so we can shoot back and destroy the enemies. So I'm going to go to our game scene.swift again and say there's a touches began method. Now, if you touch a screen and you're dead, nothing should happen. So I'll say guard is player alive, else return. Just get out immediately. If they're dead, they're dead. We don't want to shoot short bullets, right? Otherwise, make a new sprite called player weapon and kind of do the opposite of what we had for the enemy weapon. Now we'll say let's shot equals an SK sprite node. with the image named player weapon, and shot.name is player weapon. Shot.position is our player's position. Player.position. For the physics body, we're going to say physics body is an SK physics body. Again, using rectangle of because it's just much faster. Shot.size. Shot.physics body. We'll do category bit mask. What it is a collision type dot player weapon dot raw value. A shot.physics body dot collision bit mask. What it bounces against is collision type dot. In this case, we're going to use enemy dot raw value or enemy weapon dot raw value. And we'll use the same thing for its contact test bit mask as well. So it'll tell us what they collide against them as well. Then we will, correctly this time, add that to our game scene, our child shot. Now, in this one, we're only ever pointing in one direction. So you haven't got to worry about calculating the right direction using sine and cosine and then applying an impulse. We're going to say move to this location. It's much, much easier because it's a simple animation now. Always facing in that one direction. So we can say let movement equals sk action dot move to. This will want a CG point somewhere. There we go. Our CG point is going to be X 1900. So way off screen again. Suitably far off screen. And Y will be shot.position.Y. So move straight line. Duration 10, so it'll take 10 seconds to move that space. We're making another sequence. We'll say sequence equals SKAction.sequence of movement followed by dot remove from parent to destroy itself automatically at the end. And then shot.run that sequence. So it should fly off. Let's find out. Let's see what I screwed up this time. I'll press the screen. There we go. There's a little rocket flying out. It won't do anything yet, of course. It'll run into the enemy craft. Nothing actually happened though, of course. There's no actual impact happening yet. But it's actually working now. So they can shoot us. We can shoot back. I think our bullets are quite slow actually. Let's make our bullets faster. Let's say duration is 5. So it's twice as fast now. Should look a bit nicer hopefully. Let's find out. Matt Glover, thank you very much. It's very kind of you. There we go. That's much faster, isn't it? Brilliant. Okay. So now we can shoot back. And now it's time for the most complex part of the game, realistically, which is doing the actual collisions. We have to try and decide what to collide with something else and what to do about it. And if you've done SpriteKit collisions before, you'll know there's all sorts of complexity about did thing A hit thing B, did thing B hit thing A, or did both of those things happen at the same time. So we've got to be really careful how we handle collisions. Now, in our case, we want to have a little think about, should the player be destroyed? Should they be damaged? Do we subtract some shields from the player, subtract some shields from the enemy? When do we create explosions? And so forth. So I'm going to go ahead and start by saying, first, the important bit. Our game scene is an SK physics contact delegate. So I'm ready to be told when collisions happen. And in did move to view, physics world dot contact delegate is self. So tell me when collisions happen. Now we'll write the important method, which is down here. We're going to say did begin. So when a contact happens, what do you want to do? In our case, the first thing we're going to do is figure out what nodes were impacted by this. Now this is important because if you imagine node A hits node B, and at the same time node B hits node A, which is entirely possible in SpriteKit. If node A hits node B, and you destroy node B as a result of that, it'll then say, great, node B's hit node A, what do you want to do? And if you try and refer to node B again, which has been destroyed, your app will crash. You'll be super careful here. So we'll start by saying guard let node A is contact.bodya.node else return, and then guard let node B is contact.bodyb.node else return. So at this point, node A and node B are two game nodes that definitely exist in our game. We can start using them and working with them. But we don't know which one's our player, which one's our player weapon, or the enemy weapon. Either one could be node A or node B. This makes our conditions quite complicated. So I prefer to somehow get them in a sensible order. And there are so many ways you can do this. The easiest one to understand and work with in your learning is like this. Let sorted nodes equals node A, comma, node B as an array dot sorted where $0.name or empty string, because it's nil, it's optional, is less than $1.name or empty string. And that will make sure that we have enemy first, then enemy weapon, then player weapon, because they all have names that set them apart uniquely in the game. So we'll know for sure now, if our player is anywhere in there, it'll be node B, because it's less than enemy and enemy weapon. So we can say, let first node is sorted nodes 0, and, oops daisy, 0. Let second node is sorted nodes 1. And now, if second node dot name is equal to player, because it can never be the first node anymore, because it only collides with enemy and enemy weapon. So then, and they are both alphabetically before P in the alphabet, so it'll always be the first node. Second node is going to be player. If we've collided with the player, then we can say, first make sure the player is still alive. Guard player is alive, else return. If they're dead, don't carry on beating them. They're dead, leave them alone to die and rest in peace, right? If they are alive, then we're going to first destroy the other node. So if an enemy collide with us, destroy the enemy. If an enemy weapon to collide with us, destroy that too. We'll make a new SK emitter node called explosion. We haven't designed this yet, but we'll fill in a second. We'll say if let explosion is equal to SK emitter node with a file named explosion, then explosion.position is equal to first node dot position, not the player's position, the enemy's position. And then add child explosion. After that, we'll subtract 1 from a player shields property. How strong, how much health the player has. We haven't got this yet, but this will be an integer with, I mean, how hard your game want to be, right? 3, 5, 10, 20, 100. It's down to you. I'm going to say by default our player shields is 10. Take 10 hits before they finally die. So default is 10. Subtract 1 when they're hit by something. And we'll say if player shields is now 0, call a game of a method I haven't written yet, so I'll comment that out. And then remove the second node. Remove our player node. It's been destroyed now, the game's over. Regardless, remove the first node. So if the player's dead or not dead, still destroy the bullet that hit the player or the enemy that hit the player. Got to be destroyed. So that's if we collide with the player. The second option is else if the first node is an enemy. Now, if it's an enemy weapon, that's important as well. But if it's an enemy, we handle it specially. We'll say if let enemy equals first node as question mark enemy node. And the reason we have to typecast it here, rather than saying, you know, if the name is enemy, is because we want to make sure we have access to an actual enemy node type to work with. Oops, sorry, if let enemy. Because these things have shields. Shields of 3 or 5 or 1. We must subtract 1 from that when it gets hit. So we'll say enemy shields minus equals 1 when it gets hit by a player weapon or whatever. And if the enemy's shields are set to 0, again, I'll just copy and paste this code, make an explosion particle node inside there, using explosion, place it at enemy position, like that, and add child to the game scene. And remove enemy.remove from parent. So its shields are gone, this enemy's dead now, go ahead and destroy it. Regardless, we want to say no matter what it hits, if it hit the player, whatever it is, we want a second explosion based on where it hit. So we'll say, down here, again, make another explosion sprite, add that to the scene, and second node, .remove from parent. And remember, that won't destroy our player, because the player will have been caught always by this first condition up here. Because the player is sorted alphabetically after enemy and enemy weapon. So this thing here will never remove the player from the game. This is useful if you want to do things like, oh yeah, we've collided our player's weapon with the enemy, for example. That will destroy our player's weapon and hit the enemy at the same time. So that's there. The third option is two other things collided. For example, if we made the player weapon collide with enemy weapons. If that was a thing we enabled, then make them both destroyed and make a little explosion, for example. So we'll have a generic catch-all else. Again, I'll just paste in my explosion code, make another explosion like that, and we'll say place you at second node dot position, add to the scene, then remove first node, remove from parent, and remove second node, remove from parent. Boom. Okay. So that destroys the player, or destroys the enemies, or destroys the weapons, depending on what collide with what. There's quite a lot of code there, but there's a lot of logic going on, so it can needed. We do have to write this game over method though. This thing up here I took out on line 149. I'll re-enable that. We'll write game over now, because it's not very hard. We'll say func game over is player alive is false. Game's dead, finish the play now, don't make more weapons or whatever. Again, an explosion, of course, because the player is dead. We can make explosion at player position, add it to the scene, and then say let game over is sk sprite node. I've got a sprite just for this one called game over. Boom. I'll just do add child game over. It'll be sent on the screen by default. Question from Bogdan Andre. I have not currently got code to remove sk emitter nodes, and you do want that. You want to say something like dispatch async after, I don't know, 5 seconds, whatever your explosion does. We haven't made the explosion yet, so I can't say how long it's going to be. But yeah, 5 seconds is more than enough. Remove from parent automatically after it has that. So that'll end the game when the player's finally dead. We now need to define what explosion looks like. So I'll press Command N again. Choose a new particle system for SpriteKit. I'll make this one base off fire. And I'll call this thing, oops daisy. I'll call it my particle because I pressed enter too fast. I'll rename that to be explosion.sks. My mistake. The default fire one, it goes on forever and ever and ever. So you get like this infinite fire burning in space, which is not a great look. We don't want that. We want to have a birth rate and a maximum of some sort. So I have a maximum here of, I don't know, 200 or so. Try numbers out, see how they look. That looks like quite explosion-y. For range, you want this to fire in all directions, like a real puff of smoke, of fire. So I'll do 360 for the range, so it goes in all directions, like that. Beautiful. For the position range, you know, something like 32, you know, a little sort of ball around the explosion like that. That's quite nice. You might modify the speed so it goes a bit slower. So like 60, range 30, like that. Oh, hello. Sorry, my dog's come to say hello. It's an explosion, right? You can define your own explosions. It's a SpriteKit particle editor. Noodle around, see what you think looks good, basically. I prefer a much faster one, so let's go for a really fast birth rate, like 1,000, so a real bang sort of look like that, maybe even 2,000. Boom, like that, real bang. Yeah, perfect. So that's our explosion. So in theory, that will work now. Let's find out if that actually works or not. While that's running, I'll try and track the dog. Hey, you. Come here. Luna? Hey, you. Come here. Come here. Yep. Look, we've had some donations, dog. I mean, that means you can have a treat. Come on. Good girl. Oh, you're manky. Why are you so manky? Excellent. Now I'm manky too. Hooray. I'm dead. Thanks, dog. Let's try that again. I'll press stop and run it again. Anyone see explosions? Are any explosions happening at the same time or not? Let's find out. There you are. Brilliant. So I can shoot them. They can shoot me. I'm going to miss all those. I can't move yet. Shoot that. Yeah, look at that. Boom. Yeah, have it. Die. It starts to slow down a bit because the simulator isn't very fast, but it's obviously lightning fast on real devices. Yeah, look at that. Great. These ones have higher shields now, so we've got to shoot these things more. Boom. Uh-oh. Ah, dead. Anyway, yes, the dog has come to say hello. I will... come here. Hey, you. Come on. I've had like 3 donations. You can come and get another treat. Come on. Oh, you big lump. Oh, sorry. There you go. Well done. Okay. You get 3 treats. 3 treats, okay? I'll sit still. Oh, there you go. They like you more than they like me, you know. I think potentially more than they like Swift as well. You know, it's very possible, by the way, folks, that we might get a second Samoyed, because we think you enjoy having a little friend to race around with. And I found a nice rescue Samoyed, about the same age. So we may, if we're lucky, end up with 2 dogs. We'll see. Have a little friend. Anyway, I've only had 3 donations, so I thought you'll get 3 treats. So there you go. You've got to sit there and choose something for a while. Right, where were we? Ah, yes. Explosions. Right, so at this point, the game kind of works, right? They can shoot us, we can shoot them. It all kind of works, right? But obviously, it isn't much fun because we can't move around the screen. And that's where we're going to start to bring in an actual iPad. Because I want to add in core motion. So you tilt the device to move around a little bit, and then tap the screen to shoot stuff. So. In our game scene, I'm going to make a new property called let motion manager equals CM motion manager. This requires an import for SpriteKit. For core motion. Oh, Luna, got some good news for you. Jason likes you. Come here. Come on. This is from Jason. Come on. Good girl. Don't burp at me. Lovely. Anyway. So import core motion, get a new CM motion manager so we can start doing tilt detection in there as well. And then there's no point looking at me, dog. You wait for them to donate some more money. Sorry. In did move to view, I'm going to say start reading the motion tracking device immediately. So I'll say motion manager dot start accelerometer updates. So start reporting back to me what data is as we tilt the device. And now in our update method, we can start to read that. So I'm going to say in here somewhere, let's do it at the beginning, might as well. If let accelerometer data equals motion manager dot accelerometer data. If there's data to read, which it always should be, but you never know, then we're going to modify the player's position based on that. And this requires 2 interesting quirks. First, we're going to use the X accelerometer data, not the Y, because the device is tilted on its side. So what would have been X is now actually the Y. So you've got to flip it around slightly. Secondly, we're going to multiply it by a large number to make the effects more pronounced. Because no one wants to tilt like massively while trying to play, because you can't tap the screen. We want small tilts to work. So we're going to say player.position.y plus equals a CG float of accelerometer data dot acceleration dot x, so the x thing that's spinning around the landscape, times by 50. Make it a really strong, pronounced movement thing. If this was a real game shipping, you'd say to let users have bigger numbers or smaller numbers in there to control how fast they want to tilt things with. You plaguing thief. Good luck to you, my friend. Anyway, that times 50. So make it a really strong effect on the screen. Then we'll say if player.position.y is less than frame.min.y. So if they try and go off the screen, stop that dead. We'll say player.position.y is frame.min.y. And similarly, else if player.position.y is greater than frame.max.y. If they go off the other end of the screen, then we'll say player.position.y is frame.max.y. So as they tilt the device, that's fine. We want to move them around the screen freely, but we don't want to let them escape the screen. Otherwise, they'll get very confused and probably angry. And they'll probably cheat as well because they can't get hit by enemies anymore for a start. So now, hopefully, I'm going to bring in this thing over here, which is my live iPad connected to my thing. This thing here. I should be able to, hopefully, run that back on here. So I'll say OS version. I have not updated my iPad yet to 12.2. Yay. That's how much I use my iPad. I'll make it 12.0. And that should work, all being well. There we go, drops. I'm going to push the game to my iPad now. I'm going to bring it over here so I can try and actually control it on the screen. And this should, in theory, let me see that with QuickTime, while also, hopefully, letting me control it with my iPad. Having a little think, transfer a drink. Okay, so it's launching. There's my ship. I'm tilting around now so I can dodge around quite nicely, perfectly. I can now try and shoot and tap and talk. So I'll get these guys here. You die. Yeah, have it. Look at that. All right. Boom, look at that. So as you can see now, the explosions work much, much faster because it's on a real device. I can't go off the screen anymore. It forced me to stay inside the screen bounds, which is nice. These are stronger because I'm on level 2 now. So hit that one by accident. Boom, ba-doom, boom, boom. And level 3 ships come in now, so even faster and slower. I'll just whack into him. Boom. That's a bit of self-destruction there. And eventually, when you obviously do less well, if I stop firing in response, boom, game over. And the game ends. Now, the only change I'd really make to this, apart from obviously cleaning up the code a heck of a lot, is that I use an iPad Pro. I'd really want to make sure I was getting the most out from that, so I'd probably say in my game view controller, view.preferred frames per second equals 120. So give me the ProMotion style, slicker, faster playback. Robert Lee, Jobs, is that cannon fodder? Yes, it is. Jules is my phone. Jobs is my iPad. We have RJ, which is my backup server. We have Ubic, which is actually the hackingwithstuff.com web server. There we go. Super slick now, even smoother. You can probably stay on your screen. If I actually bring it up here, it'll be even better. You probably stay on the QuickTime thing by the stream, but trust me, on the iPad it looks a bit slicker and smoother again. So yes, I do love ProMotion. But you can see, at least in the bottom right corner, you see 120 FPS there. So it's using it nice and smoothly on the screen, which is fantastic. Stu, I had Stu previously. Stu was for a long time my USB thumb drive. I don't use that so much anymore, so it's kind of gone to the wayside. I might reuse that name soon. But yes, they're all cannon fodder names. I'm a massive cannon fodder fan. Anyway, that brings us to the end of our game. And we've written quite a lot of code, I think. We've written 208 lines of code roughly in GameTeam.Swift, plus some more in enemy type and enemy node and wave and bundle decoding. We've got through a heck of a lot of code in about an hour and 40 minutes, a bit longer than usual. There you go. As always, if you have questions, let me know. I should say I'm going to upload this project to the Swift on Sundays repo on GitHub shortly, containing all the code, all the assets. These assets are all public domain assets. They come from Kenny NL. He's a designer, game graphics designer. People call him Asset Jesus because he makes a lot of public domain images. Now, even though they are free and you get them from me free of charge, of course, what public domain means, you can buy them from Kenny, and I recommend you do because they're absolutely wonderful. And they cost peanuts. I mean, he priced them as low as he possibly can, and you can get game assets 1, 2, and 3 for like $30 or something, and that'll give you thousands of pictures. I mean, literally thousands of pictures to work with. There you go. So assets 1, 2, and 3, and they're amazing. The public domain for your own games. There's something like 40,000 plus assets in there to get and use for almost nothing. And he'll actually often do half price sales, which is amazing. It's just incredible. So I highly recommend you support Kenny and buy assets. Even though you can get those free from me, you can get the original vectors and stuff from him, and then use them your own way as you want to. Okay, so that ends the main section of this tutorial. If you have questions, now it's time to ask. And there's questions about the game you just made, questions about the dog, questions about gameplay kits. I see someone's whizzed by there. Whatever floats your boat, this is your chance to ask questions now. What do I think about Gameplay Kit? So Gameplay Kit is very nice. It's solving important problems because it's the kind of thing you want to commonly reuse, right? You want to have, pathfinding or random number generation or AI and so forth ahead of time. So of course you want to reuse these things. So it's very nice. The problem I have with it is that it's really not very swifty in places, and I've complained bitterly about this to the Gameplay Kit team, to the SpriteKit team, to the Swift team, publicly, privately, you name it. I've complained bitterly about Gameplay Kit's lack of swiftiness, and it's been helped by the fact that some of the worst bits have been replaced by Swift. So, for example, the one I complained about again. If you just Google up if you Google up 925 Mac radar redesign or something like that, you'll find a story about bug report. There we go. This one? No, that's years ago. Bug report tool. Bug report. Redesign. There we go. Really? I can't find it. Anyway, I whinged and helpfully managed to get the story on 9 to 5 Mac, which is really brilliant. It meant that I could whinge publicly about it, really, really clear, and it was great because there we go. Look, hey, this is me whinging about Gameplay Kit, and this is the exact radar I filed. It was absolutely terrible before iOS 9. Got better in iOS 10, but still terrible in iOS 10. So I got tired of complaining privately, so I posted the screenshot on 9 to 5 Mac when they posted the story about this thing. It's a new story out, the new version of Radar, but I got my screenshot in there whinging publicly. And fortunately, in Swift 4.2, the new shuffling system came in, which is way better, and that's great because it was hideous. Hopefully that answers your question, John Nyquist. Next question. What happens to the collision bit mask of the player to weapon? Oh, hey dog, good news. Andres Pineda says you get a treat. Come here. Come on. Good girl. There you go. Good girl. What happens if you set collision bit mask of the player to weapon? I'm not sure. I always do both, Mongo. Just try it out. I get asked questions like that a lot. What happens if I'm like, try it out. Just try it out. Can you do this thing? Is that possible? Try it out. I mean, it's the easiest possible answer. Just try it out. More about live event. Well, it's all ready to go. I mean, if you go to hackingwithswift.com/live, you will see details about the live event now. I have not announced it yet because it is imminently April Fool's Day. I don't want folks to think there's an April Fool's. So I have, I want to wait till it is safely past April Fool's Day, so like Tuesday. That's the date, July 8th and 9th in Bath, England. It's all going to charity. The charity in question is called App Camp for Girls. They run coding camps for girls in 3 cities in the US, and they're so wonderful. It's still camps, so they do fun things, campfires, songs, games, and so forth. But they say, hey, let's use Swift to make apps. And they make apps. And they make real apps with these girls. And it's a wonderful charity. So I'm really pleased to say that all profits from this, any penny we make, will be going to the charity for this. Literally, no organizer takes any money. I take no money. It's all going towards the charity. The best airport is either London Heathrow, if you're coming from a very long way, which you are, Mark, go to Heathrow and then get a train across. Or for anyone in Europe, Bristol Airport is easier. That's the closest one. It's about 35, 40 minutes away from here by car, or you can get a bus if you want to from there to Bath. If you're flying further, Heathrow will get you cheaper flights. You'll get many more flights going from New York to Heathrow. You'll save money going to Heathrow. And there's a direct train from London to Bath. So I'll do that. That's what Sean Allen did. I took him around Bath a week ago, and he came from the train there. I live in a town called Bath, which is why the conference is in Bath. Obviously, I'll be doing lots of preparation for the conference. I'll be doing all the organizing with my friends, hopefully. So I am very keen to run it in my hometown because it avoids having to worry about traveling as well. I've got enough to think about with, writing all the material, getting all the speakers over and all this other hassle. So I want to make sure that it's in my hometown so I can avoid extra hassle. Anyway, it's going to be 2 days, 1 day of talks and sessions from my favorite speakers. I think I get to fly to the event. And day 2, hands-on making tutorials with some workshop time too. I want folks to walk away with lots and lots of projects there. So it's that as well. And again, it's all for charity. If you scroll down, it is a link to where it's being held. It's in the middle of Bath. Bath's not a big town, so you can get around any hotel basically fine. I list a few. This one's 4 minutes away. This is 5 minutes away. They're all fairly close, so it's not really a problem. Our goal is the £300 ticket plus tax. Obviously, tax is out of our hands, but £300 should mean we've got enough to get the venue, lunch and coffee and snacks and stuff. Hopefully some nice swag. People like swag and stuff, but also donate some good money to charity as well, because we want App Camp to benefit as much as we can from this. So yes, that is happening. 8th and 9th in Bath. I'm looking forward to it. It's going to be massively focused on dub stuff, and I'm obviously very psyched about it as well. So we'll see. Next question. Dan O'Leary, yes, that is Kenny assets. They're amazing. Kenny's work is wonderful, and I bought all his stuff, and I've given him beyond what he asked for. It's pay what you like, because they're so good, and I want to help him, make more. So I recommend, yes, by all means, use my assets, my copy of them, because they're public domain. You can do, but pay for his as well, because he's an absolutely wonderful guy, and he makes some great stuff. How many hours on average take to prepare for these live streams? Maybe 8, maybe 6, like 6 to 8. Like next week, we're going to do. I promise you, I'm going to make next week easy. I think I'm going to base it off a talk I did in Singapore a few months ago, because the recording came out really bad, and my audio was terrible in the recording. So I've kind of wasted this nice project. So I feel bad I've wasted this project. I'll probably do next week based around that, and that's an easy project. That'll be like an hour prep maximum. But something more advanced like this, where I've got to make some JSON, I've got to test it out, try it on various iPad sizes and so forth, takes more hassle, so it takes more time. Anyway. Cypher Poet, do I see a strong future for SpriteKit? I really do. So SpriteKit Cypher Poet is obviously a fantastic way of making games. It's the #1 game system platform in Apple's frameworks. The only one they have, really. Metal, you're not going to reuse, let's face it, for games. But it's also used for, gorgeous UI. If you want a lot of the things like the activity stuff on your Apple Watch, the effects they have there is SpriteKit and SceneKit. And it's not a game, but it looks like a game because it's beautiful. And that's where SpriteKit rules, because it's all going through Metal. It's all high performance. It looks great out of the box. So I recommend that very highly. Do I plan to do app architectures? No, I don't, because that's not very interesting, let's face it. I want to make things in this time we have. I want to make sure we're actually making real stuff. And discussing architectures isn't terribly interesting. I mean, it's the kind of thing I'd do on a stage with some comedy slides behind me, perhaps, but I wouldn't want to do it in a live stream because it's a bit tedious. Yeah, so I've actually taken down most of my apps, Alexander, I'm afraid, because time. Apple, I made the first one 10 years ago this year, my first app, and so many of my apps were in the sort of iOS 4 to 6 era, or even 7 era perhaps, that when it came to things like the 32-bit cutoff a few years ago, I was like, well, do I want to update these things? No, I don't. I've got other things to do at this point. I'm writing books and doing support or doing talks, whatever. And I didn't update them, so Apple killed them all. And there are some survive. Of course, there's some survive. I had to update those for iOS 7 and 8, 9, 10, 11, 12, and so forth. But the vast majority I let die because, they don't interest me, let's face it. Anyone that made money, I've kept alive. The rest I have not kept alive. How do I save progress on iCloud? I think I have a article on that already, actually, Bogdan. Let me just check my list of example code. I think I do have an article on that. Let me just check. There we go. Boom. How to store user default options in iCloud. It's right there. Just use that. And really, whenever I have a problem in my own code, I just go to my example code and just type in here, type user defaults into my search thing, look it up, find the article, and click on it, and it's usually fine. Because I know it's all Swift 5, I know it's all checked, I know there's only one right answer, so it's done. Why is no one complaining about pings? Because it's pronounced ping. That's what it's pronounced. Ping. Ping. Oh, it's scrolled down, hopefully. Let's jump up again. Did you decide a video from Rammstein Deutschland? No, never heard of it. Why Safari instead of Chrome? I used to use Chrome all the time. I like Chrome a lot. I've been using Safari now for, I don't know, 3 months. And DuckDuckGo too, rather than Google. And Safari, I think the folks who like the Safari browser probably haven't used Chrome recently. Because Chrome is an order of magnitude better in 1,000 ways. And the annoying thing is, it's very rare that it's like, oh, obviously Chrome's better here. It's like 1,000 tiny things. 1,000 tiny things make Chrome better. Things like randomly, the view source thing will stop working for me. Like it will say, sorry, I can't work. And it will just freeze up and I will close it. Or I have to try and kill all of Safari because all the tabs have locked up. Or randomly, Twitter will show huge blank spaces in its rendering. Now, the problem is, realistically, that Chrome is being made by Google. They're forcing their own agenda through to make web pages look and work great in Chrome. And developers are not taking the time to make it look and work great in Safari as well. So it's not really Safari's fault. It doesn't work properly as well Chrome does. But it's just a fact that it doesn't. So it's very annoying. I am trying to persevere in the name of privacy. I'm trying to persevere, but it's very hard sometimes, quite frankly. Next question. Raj Kumar, I live in Bath, in England. That's where the conference is. WWC, thank you very much. Baz. Oh, Rob, you're based in Chester. I didn't realize you were living in Chester. Yes, I am getting the train to Chester tomorrow morning at crack of dawn o'clock. So yes, it'll be a busy day. And I'm speaking at 1 p.m, doing a workshop there on architectures, in fact, which you asked about architectures previously. Someone asked about that. Should come probably to the workshop tomorrow because that'll be about architectures. And I'm doing a talk on Tuesday. I'm repeating a talk I did in Amsterdam because they had a speaker drop out. And I thought, well, you've got a gap and that kind of sucks. I'll fill the gap with a repeating talk. Broadly, I don't want to repeat talks, but they had a drop out, so I had no choice really. Anyway. Do I plan to do some macOS in live streams? You know, I thought about it. I could so easily do macOS. I mean, I've got so many macOS ideas I could walk you through and teach you. The problem is, last time I mentioned that I want to release a book about Swift on Sundays, right? Or that here's the first 12 projects in one book in written form. So you can follow along at your own speed, rather than sort of trying to type along with me, which is very hard, I understand. And I think it gets very confusing if it's like, oh, here's some macOS, and here's some iOS, here's some watchOS, here's some tvOS. It's hard to follow. So I'm not really sure yet. I think the first 12, the first book, will all be iOS. After that, I might start experimenting. We've done one Vapor one, and that was very popular. But, we'll have to wait and see, basically, see how it goes. Yes, John Lycos, you're exactly right. Chrome burns through battery much faster than Safari. Safari is a better citizen on macOS. It uses less RAM and broadly less CPU power. So, yes, Chrome is much worse than that for sure. Okay, any more questions? How do you like my new mug, by the way? Appreciate it. Baz, as I could do a macOS ultimately book by doing a compendium of like, here's the first 60 Sundays, and then of which 12 are macOS perhaps. Have I used Firebase? No, I haven't. One of the many downsides there is I have in my job is that most readers want to learn about Apple tools. So I'm kind of stuck to using CloudKit and core data and Xcode and similar. But, alternatives exist. Firebase and Realm and AppCode and similar exist. My readers don't want to learn them generally, so I stick to Apple's own stuff. I'm glad you like the Unwrap app. It needs to ship. It's been sitting there unshipped for a long time. So I need to ship that thing soon, hopefully. We'll see. Lucas Dos Santos. What do I think about RX Swift and when I do a book about it? I have almost no views on RX. I like the idea. I've used the principle elsewhere, not in Swift, but in Java. I like the idea. I'm fine with the idea. The idea is fine. I haven't really had a need for it in iOS. iOS, when you structure MVC well, I find flows very naturally. The delegation system is very, very powerful. And you kind of miss that when you go to something like C#. You're missing that. So you do naturally go towards MVVM or RX or alternatives. Whereas in iOS, we have great delegation. We have all the other built-in platform patterns we're used to. They're fantastic. So I haven't really had a problem big enough that I need to deploy RX with, to be honest with you. So no book. That's the short answer. Ivan, I'm glad you enjoyed it. Pablo, I am not speaking at TriSwift San Jose. TriSwift San Jose is a different TriSwift than the one you think of. I'm going to speak at TriSwift New York, which is a session-delivered thing. The San Jose one's very different. It's a unique approach because it's where folks gather around to learn about how to make contributions to Apple's Swift compiler or standard library, or even LLVM presumably, anything around Swift. And it's wonderful. I was there last year as attendee. I only had maybe an hour or hour and a half there because I was rushing around trying to meet folks. Obviously, double a week for me is intense. And it was amazing. Folks were hunched around tables on laptops, typing away, making contributions, making pull requests to Swift. It really, really worked. If you are if you're in San Jose for Dub Week, go to TriSwift San Jose. You will enjoy it. You will commit to code to Swift if you want to. It's there. The Swift devs are there to help you write code to Swift. So I recommend it very much. Would I do a CloudKit live stream? Probably not. I'm a bit unsure about the need to do a live networking thing. Anything that involves any live data going across the wire has a risk of failure. So I am disinclined to put my trust in CloudKit on a live stream, because if it goes wrong, I can't really tell why it's gone wrong. So it's something I might hold back for episode 35 or so, a long way away. So we'll see about that one for a while, I think. For what projects would I recommend MySQL? MySQL is cheap. It's free. It's extremely fast. It's very easy to use. It's kind of comes as standard in things like PHP. It's a toss-up these days to that and Postgres, and obviously MySQL forks like Maria. So whatever interests you, really. I personally use MySQL quite a lot. Just don't use their MyISAM tables because they're obviously a bit shaky. Pankaj Kulkarni says, with Apple's open services, what will the impact be on iOS development? There'll be no impact. No impact at all. Apple relies on iOS for almost 70% of its money. 70%. It's massive. It's massive. Their movement to services like TV Plus and similar is more of a branding move. Like the way they've always said for a long time, we love music at Apple. Apple's part of our soul. Fine, it might be, very well, but regardless of whether it actually is or not, they certainly want it to look like it is. That's a branding thing. They want to look like music's at the heart of Apple. And so this for me feels very much like a branding move. We care about the glitz. We want Oprah Winfrey looking amazing on stage. We want Jennifer Aniston and other folks saying, yeah, this is amazing. Because it's good for their brand. It fits their brand of where they want to be right now. I suspect in terms of money, it will lose money for a very long time. Potentially a decade or more. And if it ever makes money, it'll make a small amount of money. I don't expect much from that. But it's a branding thing. But that means that nearly all their money, way more than 2/3, comes from iOS development, iOS apps, making iOS great. Because no one these days has an empty iPhone. Everyone's got some sort of apps on there, whether it's Facebook or Twitter or one of my apps, of course, and one of your apps. They have apps and they rely on that. So I think it's safe to say that Apple's services move will not affect developers at all. Unless you're in the arcade space, in which case, hazy. Will Xcode come to iPad? I don't know. Good question. So Xcode has its source editor is of course taken straight from Swift Playgrounds. I mean, they took that from the iOS version of Swift Playgrounds and put it onto iPad. And that's why in Xcode 9 it's like, wow, it's so much better out of the box. If you rewritten in Swift, it's beautiful, it's smooth, it's gorgeous. I mean, it was light years ahead of Xcode 8. It was, wow, night and day difference. So they've already got a large part of the work done. Obviously, they've done the first 90%, now it's the second 90%. And that involves lots more work. You know, if you look at interface builder, like storyboards and stuff, the number of options in a storyboard is huge. It's even a small one. Some things you can scroll and scroll and scroll and scroll and scroll. I haven't got to the bottom of it yet. It's just a vast amount of data. And what it means is that they'll have to get that on iPad somehow. And it'd be a really unpleasant UI right now. So what might work and what I would love to see work is if the rumors of the Swift team making a new declarative UI system built in Swift, optimized for Swift, to either sit alongside or sit on top of UIKit, where you can do code and go back to the IB again freely, like you get in Android Studio, that'd be amazing. Because that way you can type code freely, see how it looks, type some more code, see how it looks. So you get the best of both worlds. You get to see a visual layout plus code without having a billion checkboxes and steppers and who knows what else around it. So let's go to iPad. Maybe ultimately there's a lot of work that happen. Do I have some ARKit streams in mind? Sure, I could do ARKit happily. I've got loads of ARKit ideas. It's another one that requires a real device. Obviously, you want to use the camera. So yes, yes is the answer. Let's do ARKit. Not next week, though. Next week's going to be an easy one. I know exactly what I'll build next week because it went wrong in Singapore because the audio was so bad. And the recording was live, fine on stage, but recording was bad. So I'll do that next week. A nice easy one. So hopefully bring the level down a little bit for next week. There's been a few hard ones. But then episode 13, which will be like the week after or the following week, whenever it is, we will do ARKit. But remind me, though, because I will forget. Remind me on Twitter or something that we're going to do ARKit, because I will forget otherwise. Frugal can help me learn my own games in Swift. I've just shown you how to make one. And a few weeks ago, we made another one in SpriteKit. There's two right there. I've got a whole book called Dive into SpriteKit, which makes lots of SpriteKit games in code. So you can go and follow those. Yes, I can't help you, but they're there if you go and read it. Michaela's got an error. I can't debug code on the fly in a live stream, Michaela, I'm afraid. I'll push this code to GitHub shortly, and you can do a more clear compare between my code and your code. So hopefully you'll be able to see more at a glance what went wrund. I don't know what to recommend. Try of New York or a conference in Bath? That's not really a fair question. Obviously, I'm slightly biased in that one, but also Tristat invited me, so I don't want to be mean to them. Try is a wonderful, wonderful thing to have in our community. You know what Natasha has done to build up a vibrant and exciting speaker lineup. Huge events. I think they had 900 in Japan. It's a massive positive contribution to our community, which is why I've just sponsored Tristat San Jose as a sponsor, because I want to help support them any way I can. So I can't really pick between them, I'm afraid. I would say if it came to it, coming to Bath would be much cheaper, unless you happen to live in New York like Marco Pont does. Otherwise, you'll find that Bath's cheaper because it's a European flight. Walk us up with documentation. Yeah, that'd be quite a dull Sunday's event, Guillermo, I'm afraid. So I think perhaps not. But we'll see. Once I've got the apps thing, the apps bug, out of my system a little bit, once I've made like 20 or so of these doing apps, we can look at techniques, look at other things, look at maybe architectures perhaps someone asked for. But right now, I do want to focus on getting apps. I want to make apps. Because I've got some ideas I want to get out there and, teach you all to make cool stuff. Cesar Palmer, yes. How do you save data in one device and make it on all the devices? Yes, put in documents and it'll synchronize to iCloud automatically. You want to do that. If it's simple though, you can use the NS Ubiquitous Data Store, which would be easier. Here, I'll show that link. If it's small amounts of data, I think it's something like 64K. I forget how big it is, but you basically got user defaults in the cloud you can post to. And it does things like auto resolution of data. So if two people try and write, it'll pick the newest one automatically. It's quite clever and does a lot of work for you. So yeah, possible to use that instead if you can. Tech asks, would I make an app using iPhone sensors, like counting steps? I guess. I mean, if there are app things you want to look at, let me know. Right? This has got to be about what you folks want as well. Someone's asked for ARKit, so yes, we could do ARKit. Of course, we can do ARKit. Let me know. This is like Radar. If you use Apple's Bug Reporter, the more votes people cast, the more I listen to them. So 2 folks asked for ARKit, 1 folks asked for step counting. So right now, my heart's in the ARKit space. But by all means, vote early, vote often. Yeah, so I don't do a search on apple.com directly. I use Google as well, or DuckDuckGo or another search engine, because it's easier. And this is another, the old crowd will remember the old API diffs we used to get for iOS versions, and they stopped like 2 years ago, and they were wonderful. They were so nice. And some kind soul still posts them online. He's written a script to make them automatically for all the current programs. It was really clear. You click on UIKit and show you all changes up front. Here are all the 500 changes immediately. Whereas right now it's like, click on this plus sign, that squiggle means changes or whatever. So it's awfully hard to do. SpriteKit, or more SpriteKit. Okay, cool. More ARKit, fine. ARKit's definitely up there, I think, right now. Any plans, including the video feed from the camera within the UI? Oh, is it like making a custom camera? Well, I haven't got any plans for it, but, if that's what you want, we can look into it, David. Yeah. Okay. It is now 20 past 8. If you have any more questions, it's your last chance. If you don't, you can always catch me on Twitter. I am 2straws on Twitter. Follow me there, tweet me there, get me on Slack. You could email me. I am paul@hackingwithswift.com. I'm available in a number of ways. I'm on GitHub, 2straws, Reddit, 2straws, Stack Overflow, 2straws. Pretty easy to remember, I think, once you remember the 2straws part. Last chance for questions. More SpriteKit. All right, folks. I guess that's the end of the questions. Thank you very much for coming. It's been a pleasure having you as always. I'm glad you all enjoyed the event. I'll post this code once the video feeds live on YouTube, which takes about 20 minutes usually to go live. So it'll be on the GitHub along with the other 10 projects. So there's 11 there now. By all means, tweet at me, If you want ideas for the future, please like the video. Please leave a comment in the video saying you liked it. Tell your friends about it, because YouTube recommends this video to folks more if it's got more likes or more comments. The more people watch this, the more likely I am to make more videos like it. So it's really, I look at the streams and go, oh, this one's very popular, I'll make more of those. So please do tell your friends, it'd be really, really helpful. Thank you very much. Otherwise, I will catch you on Twitter. You know where to find me now, all being well. I will see you around. And of course, come to my conference. It'll be really, really great. Take care.